Life is a game of chance. The odds of surviving or facing extinction are always changing. Now, some changes are gradual, the result of a slow process in nature. Others happen in a blink, like the one that caused the extinction of the ancient dinosaurs. In 1980, a geologist named Walter Alvarez was studying rock strata in mountains north of Rome when he came across something curious, a thin, ancient layer of clay.
So this clay layer right here marks the boundary between two different geological periods.
The layer of clay marked what is known in geology as the KT boundary, a dramatic turning point in the history of the Earth about 65 million years ago, when the ancient dinosaurs mysteriously vanished. For Alvarez, here was the moment of discovery. Analyzing samples from the KT boundary, he found the clay contained extremely high levels of iridium, an element rare on Earth but abundant in space. When similar levels of iridium were found around the world, Alvarez began to wonder what could have caused it to blanket the Earth. The answer, he concluded, was the impact from an asteroid of gigantic proportions. Over 6 miles across, taller than Mount Everest, moving at a speed of 67,000 miles an hour. Dr. Elisabetta Pierazzo is a research scientist at the Planetary Science Institute in Tucson, Arizona. So how much energy did this thing have?
An energy that is about 100 million megatons of TNT. This is about 10 times the worldwide nuclear arsenal at the peak of the Cold War.
10 times the world's nuclear arsenal when it was really big?
Yes.
All in one place?
All in one point, released in a second. So that was a humongous amount of energy that was delivered to the Earth.
The devastation was colossal. A cloud of vaporized rock and debris mushroomed into the air, blocking the sun. Scorching fireballs blasted across the face of the Earth. The air became choked with poisonous gas and soot. Nearly half of all life forms on Earth perished in the apocalypse, including the ancient dinosaurs. The only piece of the puzzle missing from Alvarez's story was proof of the asteroid. If it was as big as he said it was, then it must have left quite a crater. Finally, geologists found one that just happened to be about 65 million years old. The Chicxulub crater. An immense hole, 112 miles wide, buried under a thick layer of sediment at the bottom of the Gulf of Mexico off the coast of the Yucatan Peninsula.
Yeah, so the complexity increases with the magnitude of the impact event. And
because the Chicxulub crater is underwater, this is a good place to get a sense of what happened when the asteroid hit. This is Meteor Crater, Arizona. 50,000 years ago, a meteorite about the size of a house streaked out of the sky and slammed into the Earth. It triggered an explosion greater than 20 million tons of TNT and created this, a crater 550 feet deep and 3/4 of a mile across. Room enough for 20 football fields and more than 2 million spectators. Impressive, isn't it? But remember, the asteroid that caused the KT event was the size of Mount Everest. So to visualize the crater that it made, we need something a lot bigger, like the Grand Canyon. This is the south rim. From here to the other side is 16 miles. But even that's not big enough. The asteroid that caused the KT extinction blasted a crater 8 times as large, 125 miles across, from here to the gaming tables in Las Vegas. And when the asteroid hit, it went deep as well. It's a long climb from here to the bottom of the canyon, about 1.25 miles. But according to Walter Alvarez, the asteroid made a crater that was a staggering 20 miles deep upon impact, then quickly filled in. How do scientists know all this? The evidence has come from a variety of sources. Seismic studies revealed the enormous ring-like shape of the crater. Thousands of core samples uncovered rocks with traces of having been altered by a high-impact collision. And computer modeling that calculated the explosion it would have taken to create the Chicxulub crater. But Walter Alvarez's discovery of what caused the extinction of the ancient dinosaurs is not without controversy. His asteroid scenario is at the center of an ongoing debate, with opposing scientists offering their own theories. One theory argues that intense volcanic eruptions poisoned the Earth's atmosphere and killed the ancient dinosaurs before the KT event ever occurred. But Alvarez's theory has withstood the challenge. So this has been almost 25 years, or about 25 years.
It's about, yeah.
This theory has stood that test.
Oh, this theory got stronger and stronger because scientists from many disciplines have investigated the evidence, from paleontologists to oceanographers, and their research overwhelmingly supports Walter Alvarez's discovery that the KT asteroids was responsible for the extinction of the dinosaurs.
Today, the extinction of the ancient dinosaurs is taken for granted. But for centuries, the world had no inkling that the fabled creatures ever existed. Dinosaur fossils had been turning up since ancient times, a jaw here, a claw there, but no one had a clue who or what these enormous bones belonged to. But all that began to change in the early part of the 19th century. The discovery of the dinosaur unfolded in a series of small but significant fossil finds that first brought the ancient reptiles to the attention of the scientific world. In 1822, a naturalist gave the name iguanodon to the creature whose large, chisel-shaped teeth were found protruding from a piece of sandstone in the south of England. Around the same time, Megalosaurus was named by a professor of geology after some of its bones were unearthed in a London quarry. Because so little evidence existed to prove that these reptiles had ever roamed the Earth, scientists relied heavily on their imaginations to interpret the anatomies of the giant creatures. Often they described them as oversized versions of living lizards. But with each new fossil discovery came greater understanding. By 1849, the fossils of 9 completely different reptiles had been discovered, and a British anatomist named Richard Owen created a new scientific category for their identification. He dubbed them dinosaur, meaning terrible lizard. To the world of the 1800s, their discovery was revolutionary. It helped give birth to the science of paleontology. And because these creatures were obviously extinct, the discovery stirred debate about the history of life on Earth. For 150 million years, dinosaurs dominated life on Earth. But when they were shown the exit door, it made room for other species to evolve and dominate. 65 million years later, here we are. See, if the ancient dinosaurs hadn't died out, you have to figure we wouldn't be here. So how did we all get here in the first place? Where on Earth did life emerge? Our next great discovery offered a compelling possibility for the kitchen of creation.